If we add charge to anything, say a wire or a neuron, that charge will passively spread, and as it spreads, it will attenuate. If this is an axon, we add a charge, say it's at minus 70 millivolts. We add a charge on the outside, maybe we add minus 40 millivolts worth of electrons. We're adding E minus here. Remember, charge is relative, and so when we do that, what we do is cancel out minus 40 millivolts. We now have minus 30 millivolts inside. If the rest of the membrane all the way along this axon is at minus 70, then positive charge, the more positive area here, will move positive charges all along. So this minus 70 might get to minus 50. But as this charge moves, it disperses, it spreads. Not all the charge gets to the whole region. So this one might get to minus 60, and this one might get to minus 65. If we go far enough, we would no longer be able to detect the change in charge. The charge will spread, and then as it spreads, eventually, in a typical neuron, the normal neuronal processes will bring the whole neuron back to baseline. If we were measuring that charge with an electrode outside, so this is fluid and there are ions in here, so that charge can be measured. And then we have another electrode poked into the inside, again with ions, chloride or sodium or potassium. And we had a voltmeter. If we added some charge here, such that we went from minus 70 to minus 40, then that charge would disperse, and when it reached this electrode, we would see a change. If this was so if we're at minus 70, and the charge that gets here changes that to minus 50, that would be a plus 20, a change from minus 70 to minus 50. And if this was a negative recording electrode, and this was the positive recording electrode, what we'd see is a plus 20 at a negative recording electrode. We'd see a decline, and then back to baseline as it passed. If we added positive charge to the outside, then we'd go from minus 70 to maybe minus 100. We've made the difference across there larger. Then we might go from minus 70 to minus 100. That would be a minus 30 charge at that electrode, and in that case the trace would be again 0 up until plus 30 and back down, and we'd see a trace that looked like that. The further we go, that trace would spread out, so further away it would actually spread out and be lower, and that's the attenuation of charge as we get farther and further away. What happens if we aren't measuring on the inside and outside, but instead are measuring at two locations? So if we have a positive and a negative electrode here, and these are stimulating, so we have some voltage or current source, and we add electrons here. If we were at minus 70 and we add electrons, say, that get us to the equivalent of minus 30, those cancel out and we're at minus 40. But our recording electrodes are spread out with the axon laying on top of it. So if this is a ground, because we're always measuring difference between two electrodes, here's a negative and a positive recording. These are stimulating. So we're adding a charge here, we're just recording what happens. Our trace at these two, in comparison to the ground here, our trace would be, when nothing is going on, we would be at 0 millivolts. If we add this charge here, in effect, we're making these areas more positive. When this positive charge gets to the negative recording electrode, positive to a negative is a downward deflection, positive to a positive is an upward deflection, negative to a negative is an upward deflection, and a negative to a positive is a downward. This makes it confusing, But positive to a negative, we get a downward deflection. This charge passes. Behind here, we equilibrate as this pulse of charge is moving along. And if the distance is long enough, we'd actually go back to 0. And then later, so the charge has now passed this area. Later, when the charge gets here, we have a plus to a plus. And when the charge gets there, we'd have an upward deflection. So that's passive spread of charge. The further away we went, the smaller would be the deflection. And of course, if we put in less charge, we're going to get a smaller deflection. This is electrotonic spread of charge. When you add charge to the outside of a neuron or to a wet paper towel that has ions in the wetting solution, you'll get this passive spread of charge. And this is called a stimulus artifact in physiology.